Welcome to Cosmic Whispers, where cosmic mysteries come alive. Your journey beyond the stars begins now. Picture this: a distant world, orbiting a star far, far away, 124 light-years to be exact. A world that might just hold the key to one of humanity's greatest questions. Is there life beyond Earth? Imagine a planet with conditions so similar to our own that for the first time, scientists have detected water vapor in its atmosphere. It sounds like science fiction, doesn't it? But this is no movie plot. It's real, and it's happening right now. This isn't just any distant planet. This world is known as K2-18b, and it's a rocky exoplanet that's roughly the same size as Earth. It's a bit of an oddball in the cosmic family, though. Unlike our planet, which orbits a yellow star, the Sun, K2-18b orbits a red dwarf star. These red dwarfs are the most common type of star in our galaxy, and while they are much cooler and dimmer than the Sun, they provide a stable environment that could allow planets like K2-18b to harbor liquid water, and perhaps even life. The discovery of water vapor in the atmosphere of K2-18b is an extraordinary moment in the search for extraterrestrial life. Water vapor is a key ingredient for life as we know it, and its presence on a planet so far from Earth is a huge step forward in our understanding of exoplanets. The fact that scientists have detected it on a rocky world adds an even more tantalizing twist to the story. For years we've focused on gas giants or icy moons, thinking they were the most likely candidates for harboring water. But now, with this discovery, we realize that rocky planets like K2-18b might be just as capable of hosting water in their atmospheres as their larger, more distant counterparts. But how did scientists even find water vapor on a planet that's over 100 light-years away? Here's where things get even more exciting. You might think that to detect something so far away, astronomers would need to be able to actually travel there. But in reality, it's all about sophisticated technology and brilliant methods. The discovery was made possible through a technique known as transmission spectroscopy, a cutting-edge method that allows scientists to study the light passing through a planet's atmosphere as it orbits its star. The process is simpler than it sounds. When a planet passes in front of its star, a cosmic event called a transit, some of the light from the star filters through the planet's atmosphere. Different gases in the atmosphere absorb specific wavelengths of light. These fingerprints of light tell astronomers what gases are present, and even how much of each gas there is. For K2-18b, astronomers observed several transits, allowing them to capture this starlight as it passed through the planet's atmosphere. This gave them a detailed look at the planet's atmospheric composition. This is where the magic of spectroscopy comes into play. Water vapor absorbs infrared light at specific wavelengths, like a cosmic barcode. When astronomers studied the data, they saw the unmistakable signature of water vapor. It was clear. This distant world, over 124 light-years away, has water vapor in its atmosphere. But this isn't just any water vapor. This discovery is potentially one of the most significant steps in our quest to find life elsewhere in the universe. Now here's the thing. Water vapor doesn't guarantee that life exists on K2-18b, but its presence opens the door to exciting possibilities. We know that water is essential for life as we understand it, and where there's water, there's a chance for something more, perhaps microbial life, or even more complex organisms waiting to be discovered. The discovery of water vapor on K2-18b isn't proof of life, but it is a signpost that points us toward the possibility. This discovery also changes the way we think about the types of planets that might be habitable. For years, scientists have focused primarily on finding Earth-like planets that orbit stars in the habitable zone, the region around a star where conditions are just right for liquid water to exist. While that's still an important search, K2-18b shows us that rocky planets orbiting red dwarf stars might also be prime candidates for supporting liquid water. These stars, though cooler and dimmer than our Sun, might still provide the perfect conditions for life to develop, if the planet's atmosphere is thick enough to trap water and warmth. But before we get too carried away, it's important to understand just how tricky this search for habitable planets really is. The universe is vast, and most exoplanets are incredibly hard to study. There are millions of planets out there, but the vast majority of them are too far away, too small, or too dim to observe directly. So, how did astronomers manage to detect water vapor on K2-18b in the first place? The answer lies in cutting-edge telescopes. The Hubble Space Telescope, which has been in operation since 1990, was one of the key players in this discovery. Hubble has been instrumental in studying exoplanets, capturing detailed data on their atmospheres, and revealing their chemical compositions. But even with Hubble's capabilities, studying distant exoplanets like K2-18b is incredibly difficult. That's why scientists are eagerly anticipating the James Webb Space Telescope, JWST, which launched in December 2021. JWST's infrared capabilities allow it to peer deeper into space and study the atmospheres of exoplanets in ways that were never possible before. So what's next? With this discovery, astronomers are already planning their next steps. They'll continue studying K2-18b's atmosphere to see what else they can uncover. What other gases are present? Could there be signs of biological activity? And with the power of JWST coming online, we may soon have even clearer answers. The implications of this discovery are huge. For decades, we've looked up at the stars and wondered if there are other Earths out there. The discovery of water vapor on K2-18b brings us one step closer to answering that question. It challenges our assumptions about where life could exist in the universe and opens up new possibilities for future exploration. But here's the real kicker. K2-18b might not be the only one. What if, in the future, we discover many more planets like it, with water vapor in their atmospheres, worlds that could potentially support life? The search for life beyond Earth is far from over, and this discovery is only the beginning. Now, to imagine standing on the surface of this distant world, with a sky filled with unfamiliar stars and the distant light of its red dwarf sun. Could life thrive here? Only time will tell. But the fact that we've detected water vapor is a huge step forward. As we continue to push the boundaries of space exploration, we may one day find that K2-18b is just one of many worlds where the potential for life is waiting to be uncovered. Now that we've set the stage for this exciting discovery, let's take a closer look at the science behind how astronomers were able to uncover the presence of water vapor on K2-18b. This wasn't some lucky guess or a fluke. It was the result of advanced technology, clever methodologies, and years of painstaking research. So how do astronomers peer into the atmosphere of a distant planet, 124 light-years away? And more importantly, how can they detect something as elusive as water vapor when it's scattered in the vast cosmic expanse? It all starts with a technique known as transmission spectroscopy, an incredible method that allows scientists to study the chemical composition of a planet's atmosphere. Imagine this. You're standing on a mountaintop, watching the sun dip below the horizon. As the light travels through the air, it passes through layers of gases, dust, and particles. These elements absorb light in specific patterns, almost like a cosmic fingerprint. The same thing happens when light from a distant star passes through the atmosphere of an exoplanet. The gases in the planet's atmosphere absorb certain wavelengths of light, and by studying these fingerprints, astronomers can identify the composition of the atmosphere without ever stepping foot on the planet itself. This technique is not new. Scientists have been using spectroscopy to study stars and distant galaxies for decades, but with exoplanets, it gets a bit more tricky. Exoplanets are small, distant, and often faint compared to their parent stars, making them difficult to study directly. Fortunately, the cosmos has a little trick up its sleeve, the transit method. This occurs when a planet passes in front of its parent star from our point of view. As the planet moves across the star's light, it causes a tiny dip in brightness. This is where things get really interesting. When the planet passes in front of its star, some of the starlight filters through the planet's atmosphere. As it does, the atmosphere absorbs specific wavelengths of light based on the gases it contains. So, for example, if the planet's atmosphere has water vapor, that vapor will absorb light in the infrared spectrum, a part of the electromagnetic spectrum that we can't see with the naked eye, but that telescopes like Hubble and the James Webb Space Telescope, JWST, are perfectly equipped to detect. Here's where the science gets really mind-blowing. By studying the light that passes through the atmosphere of an exoplanet, scientists can figure out what gases are present and even how much of each gas there is. It's like reading a book written by the planet itself. Every time the planet transits its star, we get another chapter in this cosmic story. The process of data analysis is meticulous. Astronomers gather the light from multiple transits, creating a detailed picture of the planet's atmosphere. This is where the real challenge comes in. K2-18b, like many exoplanets, has a complex and dynamic atmosphere. This makes it difficult to separate the signals of water vapor from all the other gases present. Fortunately, the advanced capabilities of telescopes like Hubble and JWST allow scientists to zoom in on the key wavelengths where water vapor absorbs light. Once they identified the signature of water vapor, the next challenge was confirming it. The team had to carefully eliminate other possible explanations. Could the signal be caused by something else, like another molecule or an observational error? After painstaking analysis, they confirmed that the spectral signature they observed matched that of water vapor, and not just any water vapor. This was evidence of gaseous water in the atmosphere of a rocky exoplanet. It was as if they had found a hidden treasure in the vast expanse of space. But why is this so significant? To understand this, let's take a step back and consider what makes water so special in the search for life. Water is, of course, essential to life as we know it. On Earth, water supports a vast range of biological processes, from photosynthesis to cellular functions. It provides a medium for chemical reactions to occur and is the solvent for many of life's essential compounds. So when scientists detect water vapor in the atmosphere of an exoplanet, it's a huge deal. It doesn't automatically mean there's life, but it's a sign that the basic ingredients for life may be present. This discovery also opens up new possibilities in the search for habitable planets. For years, astronomers have focused on planets that sit within the habitable zone of their stars, the region where conditions are just right for liquid water to exist. K2-18b lies within its star's habitable zone, but the real revelation here is that planets orbiting red dwarf stars, which are much cooler and dimmer than the Sun, could also potentially support water. These stars are the most common in our galaxy, and the discovery of water vapor on a rocky planet around a red dwarf star suggests that there could be countless more planets out there waiting to be studied, planets that could harbor liquid water and, just maybe, life. Now, it's important to remember that K2-18b is not Earth. It's not an exact twin of our planet, and we're still far from knowing if it could actually host life. But this discovery is just the beginning. Scientists are already planning their next steps. With the power of the James Webb Space Telescope, JWST, we might soon have even more detailed information about K2-18b's atmosphere and whether it might be able to support life. JWST's incredible ability to detect infrared light means it could provide us with even clearer insights into the composition of K2-18b's atmosphere, including the potential presence of other important gases like oxygen, methane, or carbon dioxide. The results could redefine what we think about when we search for life beyond Earth. In the near future, astronomers will also study other exoplanets to see if they too harbor water vapor. With each new discovery, the universe feels a little bit smaller and a lot more fascinating. What if we find dozens or even hundreds of planets like K2-18b, each with the potential to support life? The possibilities are endless. As we continue to improve our technology and understanding of the cosmos, we're bound to find more planets with conditions similar to Earth. Some may even have oceans, clouds, and perhaps even signs of life waiting to be discovered. But for now, K2-18b stands as a beacon, a reminder that there are other worlds out there waiting for us to unlock their mysteries. This discovery of water vapor isn't just about science, it's about hope. It's about expanding the horizon of what we thought was possible in the search for life beyond our planet. So, now that we know that water vapor has been detected on K2-18b, what does it mean for the broader search for life beyond Earth? Is this just another intriguing scientific discovery, or does it signify something deeper, something that could change the way we look at the universe? Let's explore why this discovery is not just significant for astronomers, but for all of humanity, as it challenges our understanding of where life might exist in the cosmos. First, let's consider what makes water vapor such a crucial find. Water is often called the universal solvent because it has a unique ability to dissolve a wide range of substances, making it an essential component in the chemistry of life. From a biological standpoint, water is crucial for every known life form, whether it's the vast oceans teeming with life here on Earth or the smallest cells in your body. So when astronomers detect water vapor on a distant world, it's a sign that the essential building blocks for life as we know it might be present. But here's where it gets even more interesting. K2-18b is just one of thousands of exoplanets discovered in recent years. We've only just begun to scratch the surface of this enormous universe, and the fact that we're detecting water vapor on a planet that's located over 124 light-years away suggests that other, habitable planets could be out there, waiting to be discovered. Imagine a universe filled with worlds that have the right conditions for liquid water to exist, worlds where life might be bubbling just beneath the surface, waiting to evolve and thrive. The discovery of water vapor on K2-18b challenges some long-held ideas about where life can exist. Historically, scientists have focused on finding Earth-like planets, those that are similar in size, temperature, and composition to our own planet. But K2-18b is a bit different. It's a rocky planet orbiting a red dwarf star, a star that is smaller and cooler than our Sun. These stars make up about 75% of all the stars in the Milky Way galaxy, meaning that there are potentially billions of planets in our galaxy that could have conditions similar to K2-18b. If these planets are also able to harbor water vapor, or even liquid water, then we might have to rethink our search strategy entirely. The traditional idea was that life needed to exist in the habitable zone, the area around a star where temperatures are just right for water to remain liquid. But K2-18b is challenging this notion because red dwarf stars, despite their cooler temperatures, could still offer a habitable zone where liquid water could exist on nearby planets. These planets could potentially be more common than previously thought, drastically expanding the potential for life beyond our solar system. This discovery also leads to another profound question. Could there be life on K2-18b itself? Now, we're not talking about little green men, but rather microbial life, simple organisms that could survive in the planet's atmosphere. After all, life as we know it doesn't need to be complex to be meaningful. On Earth, life began with tiny microbes billions of years ago, and they survived in extreme environments like deep ocean vents, acidic lakes, and even frozen tundras. If life could exist in such extreme environments on Earth, why couldn't it exist on a distant planet that also has liquid water? Of course, while the presence of water vapor is promising, it's not definitive proof of life. There's still a long way to go before we can say with certainty whether K2-18b or any exoplanet can host life. But the fact that we have detected a critical ingredient for life, water vapor, in such an alien environment opens up possibilities that we've never considered before. The search for microbial life is far from over, and in fact it's just beginning. One of the most fascinating aspects of this discovery is the potential it holds for future missions. As technology advances, we may be able to study exoplanets, like K2-18b, in more detail. With future telescopes and space missions, we could potentially detect not just water vapor, but also oxygen, methane, or even carbon dioxide, gases that could indicate biological processes taking place. Instruments like the James Webb Space Telescope, JWST, are already capable of studying the atmospheres of distant planets, and in the coming years, these telescopes could revolutionize our understanding of the cosmos. In fact, one of the most exciting aspects of future exoplanet research is the potential for atmospheric biosignatures. These are gases or chemical compounds that are produced by living organisms. On Earth, for instance, oxygen is produced by plants through photosynthesis. Methane is created by bacteria and other microbes in the digestive systems of animals. The presence of these gases in the atmosphere of a distant exoplanet could suggest that life is actively taking place on that planet. But there's also an important caveat here. we need to be cautious about jumping to conclusions. While water vapor is a promising sign, we cannot yet confirm that K2-18b is home to life. The scientific community is still debating the best way to identify life on exoplanets. Should we focus on looking for biosignatures, specific gases associated with life, or should we search for other, more direct forms of evidence? Some researchers argue that we need to cast a wider net and look for planets that show signs of geological activity, such as volcanic eruptions or tectonic movement, which could suggest that the planet is habitable. Others suggest that we should focus on planets that are similar to Earth in every way, hoping to find a second Earth in the habitable zone of a star like our Sun. As we continue to develop more advanced techniques for studying exoplanets, the search for life will become even more exciting. Future telescopes, like the Nancy Grace Roman Space Telescope, could bring us even closer to answering the age-old question, are we alone in the universe? As we conclude our deep dive into the remarkable discovery of water vapor on K2-18b, we must pause and reflect on the monumental implications this breakthrough has for humanity. While the scientific community is still piecing together the full unveil scope of this find, it's impossible to ignore the potential ripple effect it could have, not just on astronomy and space exploration, but on our entire view of the cosmos and our place within it. Imagine a future where humans are no longer confined to Earth, but instead are journeying to distant worlds, settling on planets that are millions of miles away. A future where interstellar travel is no longer a dream of science fiction, but a tangible reality. The discovery of water vapor on K2-18b brings us one step closer to this bold vision. It signals that the universe is not a barren, lifeless expanse, but a vast ocean of potential, a treasure chest filled with planets that could harbor life, possibly even intelligent life. It challenges the assumption that Earth is the only cradle of life in the galaxy, urging us to rethink our role in this infinite universe. This discovery isn't just a piece of scientific data, it's a window into the future of humanity's exploration. K2-18b, located more than 124 light-years away, may seem far out of reach, but advancements in space travel technology are accelerating. With the advent of next-generation telescopes like the James Webb Space Telescope, JWST, which already has the capability to examine the atmospheres of exoplanets in incredible detail, our understanding of distant worlds is expanding rapidly. Instruments like these will soon enable us to do more than just detect water vapor. We will be able to study the composition of planetary atmospheres, detect the potential presence of biosignatures, and analyze chemical markers that suggest biological activity, signs that life may indeed exist or have existed on these alien worlds. This is where the search for life beyond Earth takes a major leap forward. The presence of water vapor on K2-18b is undeniably exciting, but it's only one piece of the puzzle. To fully understand the potential for life, we need to examine the environmental conditions of this planet. For example, how thick is its atmosphere? Is there enough pressure for liquid water to exist? What is the temperature like on the surface? Is K2-18b experiencing extreme weather, or does it have a stable, life-supporting climate? And beyond just water, could other chemical building blocks of life, like carbon, nitrogen, or sulfur, be present in its atmosphere? These are just a few of the questions we will need to answer in the coming years as we continue to study this distant world. But why does it matter so much? Because the more we learn about K2-18b, the more we learn about the habitable zones of the universe. For decades, scientists have focused on finding Earth-like planets in the habitable zone, the region around a star where liquid water could exist on the surface. But now, with K2-18b, we have a planet that doesn't fall into the classic mold of what we thought was necessary for habitability. K2-18b orbits a red dwarf star, which is cooler and smaller than our Sun. These stars, though not as bright as our Sun, are incredibly common in the Milky Way, accounting for about 75% of all stars. So, the potential for planets, with liquid water and possibly life, around these stars might be far greater than we previously realized. In other words, the discovery of K2-18b is rewriting the playbook on where life might be hiding in the universe. This planet might not be the only one. There could be millions of planets around red dwarf stars, each one offering the right conditions for water, and perhaps even life, to thrive. As we find more planets in this star system, we may begin to see patterns emerge that could point us to even more promising candidates for the search for life. But what about the possibility that K2-18b might already host life? This is where things get truly thrilling. While water vapor is a strong indicator that the planet could support life, we have to remember that life doesn't need to look like us. On Earth, life exists in the most extreme environments, from the frozen deserts of Antarctica to the boiling hot vents at the bottom of the ocean. So, what if simple life forms, like bacteria or other microorganisms, are living within the clouds of water vapor? Could they survive in an environment that on the surface might seem inhospitable to us? It's a tantalizing possibility, and it fuels the imagination of scientists who dream of finding alien microbes far from Earth. However, while it's an exciting hypothesis, we need to be cautious before jumping to conclusions. Water vapor alone isn't enough to prove the existence of life. We need more evidence, and that's where future missions come in. In fact, the next step in our journey to understand K2-18b could come sooner than we think. The James Webb Space Telescope, JWST, is currently the most advanced tool at our disposal for studying exoplanet atmospheres. Its ability to capture infrared spectra allows it to peer through the clouds of distant planets and analyze their atmospheric composition. Future space missions could provide even more detailed insights into planets like K2-18b, identifying not just water vapor, but other crucial elements that could point to signs of life. For instance, gases like oxygen and methane could be indicative of biological activity, since life on Earth produces these gases as byproducts. But beyond just finding life, this discovery asks us to rethink the very nature of life itself. Could life exist in forms we've never imagined? Could it survive in environments that are vastly different from the one we know on Earth? As we continue to explore these far-off worlds, we're forced to expand our definition of life and begin asking the big questions. What is life? How can it exist in extreme conditions? Where else in the universe could we find it? The search for life beyond Earth is not just about proving we are not alone in the universe. It's about understanding what it means to be alive, how life can evolve, and where our species fits into the grand story of the cosmos. The discovery of water vapor on K2-18b is a beacon in this cosmic journey, lighting the way for future generations of explorers. In the end, we may never have all the answers. But that's the beauty of exploration. It's the never-ending pursuit of knowledge, and the discoveries we make along the way can inspire new ideas, new technologies, and new dreams. Who knows? The next great leap forward might be just around the corner, waiting for the brave souls willing to take it. If you've enjoyed diving deep into the discovery of water vapor on K2-18b and its implications for life beyond Earth, be sure to like this video, share it with fellow explorers, and let us know your thoughts in the comments below. What do you think? Is K2-18b just the beginning of a new era of exploration? Let's keep the conversation going, because the mysteries of the universe are far from over.